Welcome to the Deep Dive. You're here because, let's face it, you want to understand skincare, properly understand it, beyond the flashy ad.
Yeah, beyond the miracle promises and the marketing hype.
Exactly. You want to know what really works based on, actual science without needing a PhD.
And that's precisely what we're getting into today. We've been taking a really close look at XCare AI.
Right. This project that came out of the Google Gen AI intensive course Capstone on Kaggle. It's quite interesting.
It really is. What jumped out at us straight away is its core principle. It's all about the science first, not the marketing. The sources we looked at describe how this project was developed by Annber and Alexandr Malashenko aims to be your personal skincare guide, but with a really crucial difference.
Okay, what's the difference?
It's powered by generative AI and something called Retrieval-Augmented Generation, or RAG. We'll unpack that later, I'm sure. Yeah. But its mission, essentially, is to give you advice that's rooted in actual scientific databases, ingredients, research papers, and it deliberately steers clear of those, trendy suggestions you see everywhere.
Gotcha. So it's trying to be the opposite of just scrolling through Instagram ads for skincare.
Pretty much. It started out apparently as a Python prototype, kind of behind the scenes.
Right, like an experiment.
Exactly, before it grew into a full web application that you could actually interact with.
So it's had a bit of a journey.
But it all comes back to this idea of bringing real science into your daily routine. Okay, so let's dig into that. Why is this focus on science so important for someone just trying to figure out what moisturizer to buy?
Well, think about the sheer amount of information out there. And let's be honest, a lot of it can be confusing, maybe even misleading sometimes.
Definitely. You see buzzwords everywhere.
Exactly. Bold claims are easy to make. Ingredients become overnight stars. It's really hard to know what's actually got solid science behind it.
So XCare AI tries to tackle that head on. Evidence is the priority. The goal is practical, science-based recommendations, but tailored specifically to you and your skin, not just based on the latest ad campaign.
Okay, that makes a lot of sense. So functionally, what does XCare AI actually do? What's its main job?
So its core job, based on what we read, is pretty comprehensive. First, it taps into these big scientific databases, loads of info on ingredients, research.
Okay.
Then it analyzes your specific needs. So it looks at the questions you ask it, your skin type. Apparently there's a questionnaire involved.
Right.
And it can even look at pictures of products. Like if you upload a photo of a bottle.
How does it do that? Read the label.
Yeah. Using OCR, optical character recognition, it can actually read the ingredient list off the label image you upload.
Wow. Okay.
And finally, it gives you its recommendations in this structured format, JSON. Which sounds technical, but basically means it's super organized.
And that probably helps make it clear and maybe could be used by other apps later.
Exactly. It's not just a wall of text. It's structured information.
So it's taking in specifics about you, specifics about products, and then connecting that to the science. It sounds complex to build, though.
Yeah.
What were the big steps involved? The building blocks.
Oh, absolutely. Building something like this isn't trivial. First, you've got the basic setup, right? Getting the development environment ready, Python, then moving it to Kaggle for the course.
Right, the platform.
Then a huge step is integrating all the data. You've got product info, the research papers, the questionnaire data, getting all that together and usable.
Okay.
Then comes the real AI bit, implementing that RAG pipeline. That's core to its intelligence.
We'll definitely need to circle back to ARG.
For sure. Then, obviously, getting the AI model they use, Gemini, to actually generate useful recommendations, that's a major objective.
Image part.
Yeah, enabling it to understand images using PyTesseract and also Gemini itself for that OCR capability.
Okay.
And then, of course, building the actual web application, the part you see, the front end and the engine room, the back end.
Right.
Plus, they had to think about the future, planning for how it might expand.
It really does sound like a lot of interconnected pieces. And it all started in this Google Gen AI course. How did that course influence the final product? What specific things from the course are baked into XCare AI?
That's a great question because it shows how this stuff translates from learning to, doing. The course covered things like foundational models and prompt engineering.
Okay, so teaching them how to talk to the AI effectively.
Exactly. How to ask Gemini the right questions to get good, accurate skincare advice back. Then there was stuff on embeddings and vector stores.
Right. Crucial for the RJ part.
Yeah.
For finding relevant info quickly.
Precisely. That's the foundation for efficiently searching through all that scientific data. The course also touched on generative AI agents, the principles behind building an assistant like this.
Yep.
And interestingly, they talked about specialized AIs for specific fields, like medicine med-pol-em was mentioned. That probably inspired XCare AI's focus on scientific credibility within skincare.
Applying that domain-specific idea.
Yeah. And finally, MLOps for generative AI, basically. How to build the backend so it's robust and ready for people to actually use it without it falling over.
So the course really provided the toolkit, and they built this on Kaggle, you mentioned. What role did Kaggle play? Was it just a place to run the code?
It was more than that. Kaggle was pretty central for this project, it seems. It gave them access to serious computing power, which you definitely need for this kind of AI work.
Right, GPUs and stuff.
Exactly, and a pre-configured environment, which saves setup time. But also, crucially, Kaggle hosts tons of data sets.
So they found the data there.
Well, they use specific data sets hosted there, yeah. Things like products dataset complete.json, sedit dataset.json, that's sedit set.js, like SS likely stands for scientific evidence, maybe research summaries, and skin type questionnaire.json.
Okay.
And beyond the tech side, Kaggle's also a community. You can get feedback, collaborate. It seems like they started locally, but Kaggle was key for the course Capstone development.
Makes sense. Let's zoom in on the tech a bit. That initial Kaggle prototype, the notebook file they mentioned, what were the key steps in that?
Right. The XCare AI personalized skincare assistant.ipynb. So first step was just making sure the environment was okay, checking files were there, standard stuff.
Yep.
Then installing the necessary software libraries, Google Generative-Fi to talk to Gemini, sentence transformers.
What are sentence transformers again?
They're AI models that understand the meaning of text, not just keywords. Super important for finding genuinely related research or products.
Got it. Semantic understanding.
Exactly. And Tesseract, for that first pass at reading text from images, they apparently hit a snag with something called CUDA-Python, a dependency conflict they had to sort out.
Always happens.
Always. Then, loading the data we just talked about. After that, setting up the core RIG pipeline using those sentence transformers to create the digital fingerprints for the text.
Right.
Then experimenting with actually generating recommendations using Gemini and trying out the OCR with both Tesseract and Gemini's image skills.
Okay, so proving the concept.
Yeah, basically. The notebook finished up by summarizing findings, noting limitations always important, and outlining the next steps towards the full app.
So how did they bridge that gap from notebook experiment to the full web application? What are the main parts of the final user-facing thing?
So the web app took that core logic and wrapped it in, well, a usable package. You've got the front-end index.html, which is what you see. It's a chat interface.
Simple enough.
Yeah, pretty intuitive. It lets you change themes, switch language, English and Russian were mentioned, and crucially, upload those product images.
Okay. And the backend, the engine.
That's appap.py, built using FastAPI. Think of FastAPI as a really efficient framework for handling requests coming from your browser. It manages everything behind the scenes.
Like what?
It takes your input, manages your session, so it remembers the conversation context.
So it knows what you asked before.
Right. It runs the RAG process to find relevant info, sends the request off to Gemini, gets the response back, formats it, all the heavy lifting.
And it uses the same data. Products, research.
Yep. Still relies on those data sets, plus any images you upload. And the output is that structured JSON we talked about.
With the different sections.
Yes.
Skin analysis, recommendations.
Exactly.
Yeah.
Skin analysis, product recommendations with explanations, scientific evidence linking back to research, and even a suggested care routine, morning and evening, plus the extracted ingredients if you uploaded an image.
That sounds really comprehensive. It's
Okay.
a lot working together. What are the key technologies making it all happen?
Okay, the tech stack is pretty modern. At the heart, you have Google Gemini. That's doing the core generation and image analysis.
Right.
For creating those text embeddings, understanding meaning, it's sentence transformers.
Yeah.
Specifically, the all-minnow LM L6 V2 model known for being efficient.
Yeah.
For the initial OCR attempt, it's Tesseract, often paired with OpenCV for image cleanup beforehand.
To improve accuracy.
Yeah. The web backend is FastAPI running on a server called Unicorn. For managing sessions and maybe other quick access data, they use Redis.
Which is super fast.
Very fast, yeah. Then for data crunching and analysis, standard Python libraries, NumPy, Pandas, and scikit-learn.
The usual suspects for data science.
Pretty much. The web pages themselves are built using Jinja 2 templates, and LangDetect figures out if you're typing in English or Russian.
It's a solid lineup of tools. You highlighted Gemini there. Can you elaborate a bit more on its specific jobs within XCare AI?
Sure. Gemini wears a few hats here. Its main job is generating those scientifically grounded recommendations. It takes your question, plus the context provided by the RS retrieval, the relevant products and research snippets.
And synthesizes it all.
Exactly, into that structured advice. Second, it's crucial for image understanding. If Pytesseract fails on a blurry label,
Gemini steps in.
Gemini steps in. It can analyze the image directly and pull out the ingredients much more robustly sometimes. That's a huge plus for accuracy.
Definitely.
And third, Gemini's multilingual capabilities allow the whole system to work in both English and Russian. Understanding queries, generating responses in either language.
That dual OCR approach is clever. Okay, let's finally unpack RH properly. Retrieval-Augmented Generation. How does that work here, and why is it so key for keeping the advice scientific?
Okay, RH. Think of it like giving the AI a targeted cheat sheet before it answers your question. First step, embedding generation. All the product info and research articles are converted into those meaning fingerprints embeddings using sentence transformers.
Got it, capturing the essence.
Right. Then, when you ask something like, what helps with acne, your question also gets turned into an embedding.
Okay.
Step 2, vector search. The system compares your question's embedding to all the product and research embeddings using math cosine similarity to find the closest matches in meaning.
So for acne, it might find products with salicylic acid research on its effects.
Precisely. It retrieves, say, the top 2 products and top 2 research articles most relevant to acne. This retrieval is the key to grounding the answer in specific evidence.
Right, it's not just making stuff up.
Exactly. Step 3, augmentation. The system takes your original question, and the text it just retrieved the product details, the research snippets, and bundles it all together into a prompt for Gemini.
So Gemini gets the context with the question.
Yes. So Gemini isn't just answering what helps with acne based on its general knowledge. It's answering based on the specific information about salicylic acid products and research the system just found. That's how it stays evidence-based.
That makes perfect sense. It's like giving it specific reading material for the question and generating the actual recommendation text. How do they ensure it comes out in that nice structured format?
That comes down to prompt engineering. Basically writing very specific instructions for Gemini.
Like a recipe.
Kinda, yeah. The prompts tell Gemini exactly what sections to include skin analysis, product recommendations, why those products, linking to the evidence, the routine.
Yeah.
They also built in retry logic. If the connection to Gemini hiccups, which can happen with APIs, the system just tries again automatically. Makes it more robust.
Good practice.
And once Gemini replies, the system parses that response, breaking it down into those clean JSON sections for display.
And we already touched on the image processing Pytesseract first, with OpenCV helping, and then Gemini as the powerful backup.
Exactly that, a two-pronged approach. Try the standard OCR first, maybe after cleaning the image up a bit with OpenCV to improve contrast or sharpness.
Right.
But if that doesn't work well, maybe the label is weird or the picture isn't great, it falls back to Gemini's more advanced image analysis. It really maximizes the chance of getting that ingredient list right.
Accuracy seems paramount. Okay, shifting to the user side, what's the interface like? How does it feel to use?
It's designed to be pretty straightforward. The main interaction is a chat window, which feels familiar to most people.
Like texting an expert.
Sort of, yeah. You can toggle between light and dark themes, choose English or Russian, and there's a clear way to upload those product images.
Okay.
Wow.
And behind the scenes, you mentioned sessions.
Yeah. The Fast API backend manages your session using Redis. It keeps track of your conversation for a limited time. The sources mentioned 7 days, so it has context if you come back.
Handy.
And the multilingual support is built in throughout. Even the chat messages themselves are styled a bit to highlight things like ingredient names or products, making it easier to scan.
So user-friendliness was clearly a goal.
Yeah.
Okay, if we boil it all down, what are the absolute standout features? What makes XCare AI different?
I'd say number 1 is the scientific credibility. That's the foundation. Second, the personalization. It uses your skin type, your questions, even product images.
Right.
Third, that clever image understanding with the dual OCR approach. That adds a layer of accuracy. Fourth, the user-friendly interface, including the multilingual support. And finally, the tech stack suggests it's built for scalability. It seems ready to grow.
And speaking of growth, the future plans sound incredibly ambitious. way beyond just face creams.
Oh yeah, the vision is huge. They're talking about expanding into hair care product advice, solutions for hair problems, then decorative cosmetics, makeup recommendations based on skin type and appearance,
Okay, that makes sense.
then even oral care product advice, prevention tips, and potentially health and fitness, nutrition, activity, lifestyle advice, again, rooted in research and user data.
Wow.
But the really big piece seems to be this personal dashboard or medical profile.
What would that involve?
The idea is a secure place to store all your relevant info. Your skincare cosmetics history, what you used, did it work, any reactions, plus broader health history test results, medical info.
Like a personal health record focused on wellness.
Exactly. And the AI would analyze all that data to create super personalized wellness programs, potentially identify health risks earlier, offer quality of life tips. The goal is an intelligent platform for overall well-being.
That's quite a leap. From skincare assistant to holistic wellness platform.
Yeah.
It really shows the potential when you build AI on solid evidence, doesn't it?
It really does. Even just the current XCare AI concept shows the value of shifting focus from marketing trends to actual science and beauty and wellness.
Absolutely. So as we wrap up this deep dive, maybe the thing to think about is, what happens when AI tools like this, ones that prioritize scientific proof, become more common?
Right. How could that change how we think about personal care, about beauty, about wellness itself?
And could this science-first AI approach be applied elsewhere in our lives? Definitely something to ponder. Thanks for joining us for this look into XCare AI.